In this video, let's see an IT JEE previous year question which was asked in the year 1999 for 2 marks, and it was based on the topic of inverse trigonometric functions. We have already seen and understood some questions of inverse trigonometric functions. We also know the formulas, and now we are about to getting into the depth of the previous year IT JEE questions. Talking about the analysis that I have done for the previous year questions, inverse trigonometric functions as such does not have much weightage. In the past 37 years, there are hardly 15 questions that have actually appeared. But yes, this is a very scoring chapter, and so we cannot leave anything as such for the competition level. Let's see what the question has to say, and let's get started by solving this previous year IT JEE question. Let's read the question together. The question says the number of real solutions for a function, an equation that is given to me. It is tan inverse root x into x plus 1 plus sine inverse root x square plus x plus 1 is equal to pi by 2. So that means I am supposed to know how many real solutions do actually exist for this equation. So the options are 0, 1, 2 and infinite. That means, are there 0 real solutions, or 1 real solutions, or 2, or infinite? So we are supposed to tick the correct option by solving it. Let's see how to solve this question. I will be writing the heading as solution. Now, we have a square root function at both the terms, in tan inverse also, in sine inverse also. And there is something very peculiar about this square root function, that the square root function is always a non-negative quantity. That means it is always greater than equal to 0. So, if this happens, then x into x plus 1, which is a square root quantity, can never be negative. So, what will happen? It will happen that x into x plus 1 will always be greater than equal to 0, because it is a square root quantity. Now, same goes for the next term, which is under root x square plus x plus 1. Even this term has to be a positive quantity, or it can be equal to 0, or what? We will see that. Now, x square plus x plus 1 is a term which has something in the independent variable x and another constant added to it 1. Now, in this condition, as per the previous also, wherein we saw that yes, I have my x square plus x greater than equal to 0. If you combine both these things, you get what? You get x square plus x greater than equal to 0, but here the same thing is what? It is equal to 1. Because if it has the minimum value equal to 0, you put the value 0 here, you get 0 plus 1 equal to 1. So that means what? That means my x square plus x plus 1 has to be equal to 1 in the minimum situation. Why? Because minimum value is 0, and 0 when added to 1 will give me 1. So the value has to be 1. Now, if this happens, then x square plus x is equal to 0. Why? Because 1 minus 1 equal to 0, which gives me back what I obtained from here. Now, according to this case, I can get x as common. It is x plus 1 equal to 0. Now, 2 solutions are there, 2 things are multiplied. When 2 things are multiplied and it becomes equal to 0, the product, so it is either x is equal to 0 or x is equal to minus 1. If x is equal to 0, the product is 0. If x is equal to minus 1, again the product is 0. So that means I have basically 2 real solutions. Why real only? Because I was asked about the number of real solutions only. So how many real solutions do I get to this question, which was asked in the year 1999 for 2 marks? It is 1 real solution is 0, the other is minus 1. So which is the correct option? The correct option is option number C, which has the real solutions as 2.